All right, these problems are from our 12.4 day 2 notes. We're going to look at more difficult derivatives, specifically functions that include square roots. So the steps are the same, it's just now our function has square roots, so that's something that we'll have to be careful with. So the first step is to find the slope of the secant line, which is the difference quotient f of x plus h minus f of x all over h. So when I'm evaluating the function at the quantity x plus h, I'm plugging in x plus h everywhere there's an x. So I have square root of x plus h plus 7. Then I'm subtracting f of x. So I'm subtracting the function, which is x plus 7. And then this is all over h. When we're dealing with these square roots, this might start to look familiar. We want to multiply by the conjugate. So I'm looking at the numerator, and I know that I have to multiply top and bottom by the conjugate, which is just switching that negative sign in between the two square roots to a plus sign. So I am multiplying top and bottom by the square root of x plus h plus 7 plus the square root of x plus 7. And that goes top and bottom. Okay, your second step is to multiply your numerators, and the good thing about this is those square roots should be canceling each other out, right? And if you remember when we dealt with the conjugate before, this is technically like a difference of squares, so those middle terms are going to cancel. So your shortcut is just to take the first term and multiply it by the first term. Anytime you take a square root and multiply by itself, you're just left with what's underneath. And then you're going to multiply the second term with the second term. And again, taking a square root and multiplying by itself is just going to leave you with what's underneath. Now, just make sure you have parentheses there because you're subtracting that entire quantity, right? Now, the denominator, do not do extra work for yourself. Do not multiply anything out. Just keep that h in front and keep all that square root mess by itself here. Okay, so we're just going to clean up the numerator a little bit. So I have x plus h plus 7 minus x and minus 7. And this whole mess in the denominator. All right, at this point, remember everything without an h should cancel. So those x's cancel, those 7's cancel. And if you notice, the only thing left in the numerator is an h. And that will cancel with the h on the denominator. So just be careful what you have left. There's still a 1 in the numerator. And then you have this square root mess in the bottom. Okay, so here is our first accomplishment. We found the slope of the secant line. All right, next step is to take the derivative, which is the limit as h approaches 0 of that slope of your secant line, which means any h is going to be replaced with 0. So this h is gone. So what we're left with is 1 over the square root of x plus 7 plus the square root of x plus 7. Well, isn't that the same as 1 over 2 square root of x plus 7? Okay, now if we are going to rationalize, which we probably should, we're going to have to multiply top and bottom by the square root of x plus 7. So the numerator, we're going to have the square root of x plus 7. The denominator, we're going to have 2 times the quantity x plus 7. All right, now we need to look at the point that they gave us, negative 3, 2. So I am going to evaluate the derivative at that x value, which is negative 3. And it looks like I should get 2 over 8, which reduces to 1/4. So there's your slope. So now I'm going to use point slope form with the point that we just found and the slope that was given to us. And we are all done. Okay, starting example 4. I already have written out the slope of our secant line. And in order to start simplifying this, we're going to have to multiply by the conjugate, top and bottom. So this is square root of x plus h minus 2 plus square root of x minus 2. And if we multiply that to the top, we also have to do that to the bottom. All right, in the numerator, remember, this is like a difference of squares, so those middle terms are going to cancel out. So essentially all you're doing is first term times first term, and whenever you multiply square roots by themselves, the square root essentially goes away. So we're left with x plus h minus 2, and then go ahead and multiply your last terms, which is going to be a minus the quantity x minus 2. And then remember, in the bottom, there is absolutely no need to multiply this mess because it's actually going to work out in our favor if we let it as is. Okay, I am simplifying the top a bit. So I have x plus h minus 2 minus x plus 2, and then the mess on the bottom. And at this point, I am looking for everything without an h to cancel. So I have the x's gone, the 2's gone, and I'm only left with one h on the top, which is going to cancel with the one h on the bottom. So we are left with 1 over square root of x plus h minus 2 plus square root of x minus 2. Okay, so then the next step is to take the derivative, which is taking the limit as h approaches 0 of that slope of your secant line. So when h becomes 0, that h is going to go away. So we're going to be left with 1 over 2 of the x minus 2 under the square root. So if we rationalize this, we're going to have x minus 2 under the square root in the numerator, and then 2 times the quantity x minus 2 in the denominator. So at this point, our point is 5 comma root 3. So we're going to evaluate the derivative at 5. Looks like this is going to be root 3 over 6. So that's our slope. So then for the point slope form, we have y minus root 3 equals your slope of root 3 over 6 times x minus 5. Looks kind of funky, but that's your answer.